Okay, and let me brief before we do the discussion on the section 6.2. And in this section, we're talking about just one technique called integration by substitution. And this is quite useful technique. With this substitution technique, we can actually enlarge your capability of doing the integration into at least double or maybe triple of the capacity you already have. But of course, if your capacity of doing integration is zero, then no matter how large I try to extend, it's still zero. So you got to have something to be extended. Okay, so that means you have to learn 6.1 to get original or basic capability. Then I can extend you to triple of your origin. Okay. And substitution means we are going to substitute something in new integration form into a new type with a simple format which can fit into the basic rules we already learned in 6.1. Okay, so the key issue is to find a term to be substituted. All right, and in order to do so, we have several steps to be followed. The first one, you have to find that particular function, and we use g as the function we are going to have, and replace the g into a new variable called u. Okay, of course, if your variable originally is u, then you probably have to substitute by some other character, maybe y or some other terms. Anyway, in general, regularly, our input originally should be x. So consider some function of x, say g of x, substituted by a character named u. And this part should be in your integration in the form of a composite type. Okay, so that must be something already in your integration terms, and with very obvious part that can recognize right away. Okay, and after the first step, the second step, we have to find the derivative for this new variable. So we have to find the du, and usually our process is starting from u equals to g of x, and then we have du equals du dx equals to g prime of x. Okay, and that is what we have been learning in previous semester. However, in this semester, since we are going to do the integration, so this format is not useful. Therefore, we rewrite this particular result into a more useful sentence. Say du equals to g prime dx. That is very similar to we move our dx to the other side of the equal sign. So du equal to g prime of dx. So in the right hand side, everything is in terms of x. In the left hand side, everything is in terms of u. So after this step, we can transform our integration from the integral variable x into integral variable u. And that's the purpose of substitution. So in the third step, substitute everything with g of x into variable u, and substitute everything with g prime of x dx into du. And after this step, hopefully your integration format will be totally become available integration with variable u. Okay, and that is what we are going to have. And after that, we expect him in this stage, x having totally replaced by u with two parts. First is the variable x through g function, g of x substituted by u. Second part, d of x combined with g prime of x will be replaced by du. So after these two parts, the new integration format has only integration variable u only. Originally, the integration variable is x. Now after this step of 3, the integration format become available u only. Okay, and then you can apply to all the integration rules we have been learned in 6.1. Okay, and that's the purpose of substitution. All right, and after that, expecting you come out with the integration result with the indefinite integration format, that is some function plus a constant c. And remember, in this stage, your integration result is in terms of the variable u. So the final stage, you are going to bring the bring the x through g function back to the position of u. So replace whatever the u in your new result by g of x. And that will complete your whole process of substitution technique. Okay, so basically you have 5 of them. First, identify which variable, which function you are going to replace, and calculate du along with dx. What is the relation between du and dx? And then rewrite your whole integration into an integration with a variable u. And step 4, that is the most important part. You have to apply the rules in order to find the result of your indefinite integration. Okay, and the last step, you have to bring that back, bring the variable x back. Okay, and we do not have many other rules in here. There's only one kind of a procedure asks you to follow. So we are going to pay a lot of attention on doing the practice. Okay, and up to now, any questions? All right, and I have quite a lot of exercise to be practiced. The first one is question number 2. Question number 2. The integration originally in terms of variable x is 4x and 2 times x squared plus by 1 raised to the power 7 dx. Okay, and according to our step, the first one you must find u equal to g of x, and then you are going to do du equal to g prime of x dx. So that means you are going to identify which one will be your g of x. Okay, and as we mentioned, your g of x should we come out with a composite form f of g of x. So must be the whole function are using g of x as its original code. All right, so that's the part. And based on that, it's very easy to recognize. You might want to use this part as your g of x. Okay, so let's check if that's possible or not. And so, as we suggest here, we have 2x plus 1 as our input. The g of x and this one are going to be substituted. And therefore, we have to make sure that g prime of x can be found somewhere in the integration format. Okay, and happen to be, in this case, after the derivative, 2x squared plus 1 should equals to 4x, right? So we have 4x. Okay, and where can we find 4x? happen to be in here, right? So we combine 4x with the x, and I should not forget about dx. Okay, so this part can be found in your original integration terms. Okay, and if you check, the shaded part of yellow is completely found in the inside the parentheses. So inside the parentheses, to the power of 7, we do have 2x squared plus 1. And outside of that, we have a 4x dx, the yellow shaded part. They are totally form the whole integration terms. Okay, so the next step will be this portion become u to the power of 7, and this portion, the blue shaded part, will be our du. So let me make shaded part again. The yellow one rewrite as u. The blue one rewrite as du. Okay. So this is step number 3. All right. Now it becomes a very simple integration form, but this time the variable is u. And now what kind of rules you can apply? That's a power rule, right? U to the power of 7 du. So your answer for this particular variable should be u to the power of 8, 1 over 8 plus constant c, and apply the power rule. Right? Remember in the section 6.1, I do suggest no matter what kind of rules you have in the learning stage, you better write it down. Okay, so you better put a note in here. This is applying the power rule. Okay, so you can have this result. Now the last step, 1 over 8, and whatever the u is, you're going to put that substitution back, and this is still the variable, the function you substitute. Okay. All right. And now back to our beginning question. It's an integration with a variable x. And after the substitution, we come out in the final stage, still a function with variable x. And in between, we, through the help of substitution, u equal to g of x, become a new integration format, which will be very easy to follow the rules we have learned in section 6.1. And then you can come out with the final result. Okay, so this is exercise number 2 in your book. Okay, any questions? All right, so let's try something a little bit difficult. And that's number 4. This time we have a little bit more longer terms. Okay. Well, can somebody check for me? I forgot it. Is there have any power in here? In the question number 4, section 6.2, is there any power? No?
Power 4.
Power 4. Okay, thank you. All right. Okay. Now, it seems obvious, at least for this moment, this should be our u. right? And we hope this will be our G prime, right? Okay, and in the beginning of this section of this exercise, almost all the questions follow the same thing, like this. Inside the parentheses, you take as G of X, and outside the parentheses, that expecting should be G prime. But remember, not all of them. Not necessarily all the questions you've been asked later will be this type. So before we go to the substitution, you have to check if this is the case. That is, inside the parentheses, you have G of X. Outside the parentheses, you have G prime of X. And if that is not the case, then that means substitution may not work for this particular question. Okay, so before we go to the U equals to G of X and du equals to G prime of X dx, you better check it. So we can take a look. The yellow shaded part, x to the power 3. After derivative, we have 3x squared. So we do have that term, right? And the second part, sorry, I believe I am mistaken. This should be the x. Yeah, this should be the x. So the second part, second term, inside the parentheses, we have x squared with minus sign in front. So the derivative, we have negative 2x. So we do have that term, right? And the last one, we have x. After derivative is 1. So we check term by term and found that is the case. Inside the parentheses, if we using as the G of X, then outside the parentheses happen to be G prime. Okay, so we're very comfortable to say we should let our U function become x to the power 3 minus x squared plus by x, and then we are pretty sure 3 times x squared minus by 2x plus by 1 is G prime, so we should let this term multiply by dx as du. Okay, and then we mark it again. This should be our yellow marked part, shaded part, and this should be our blue shaded part. Okay, and nothing left. All the terms with blue shaded part and also the yellow shaded part occupy the whole integration term. So that become u to the power 4 du. Okay, therefore, power rule apply. We have u to the power of 5, 1 over 5, plus a constant c. Okay, and now the final stage. We are going to bring the variable x function back. So we have x to the power 3 minus by x squared plus by x to the power 5 plus a constant c. Okay, so this will be the final result for the integration of parentheses 3x squared minus by 2x plus 1 multiplied by x to the power 3 minus by x squared plus by x to the power 4. Okay, and we recognize that it doesn't really matter what the power is, right? As long as it can be formed as a composite function, right? Power 7 is still a composite function. Power 4 is still a composite function as long as you have g of x being substituted. Okay, so that becomes a kind of a pattern for you to follow. So that's then it goes to okay. Then it goes to the next stage. Okay. Now, question number 10. The integration form is x squared 2 x to the power 3 plus by 3 to the power 4 and dx. Okay, now it probably will be fine if we have this one as the t of x. Then we have to check if the outside part is g prime of x, and happen to be in this case g prime of x is 6x to the power 2, and we don't have 6 times x to the power 2. Okay, so it started different now. That means you have to do something more in order to fit into the integration rule. So here we're still using u equals to g of x, and that is equal to 2 times x to the power 3 plus by 3. And our du is equals to g prime of x dx, and that is equal to 6x squared dx. Okay, now we have to be careful. This time, we only have x squared dx. That means we only have this portion. We do not have a 6. That will give you multiplication needed. That is, our 1 over 6 du will equals to x squared dx. Okay, so substitution will be slightly different now. The inside still u to the power 4. And the dx x squared is now equal to 1 over 6 du. Okay, that's no longer du alone. You have to make some kind of adjustment to bring the constant back. Okay, and after that, the integration rule can be applied. First, we are going to bring 1 over 6 to the front. That is the constant multiplication rule, right? So we bring the 1 over 6 to the front, and then we take the power rule, u to the power 5, 1 over 5, and plus a constant c. So here we have constant multiplication rule, and here we have power rule. Okay, so 2 rules apply in this case. And finally, we have to bring the t function, the g of x back. And also in the same time, we simplify the coefficient, multiply 1 over 6 by 1 over 5. So 1 over 30 and 2x to the power 3 plus by 3 to the power of 5 plus a constant c. Okay, so slightly different from direct substitution. We have to modify a little bit in order to make sure that the substitution is substituted precisely. Okay, And this is number 10. Okay. Any questions? Okay. And up to this stage, all the composite function seems to be a single power. Okay. And so let me bring you a little bit different in a format. That's number 12. Okay, so the integration is x squared square root of x to the power 3 minus by 1 dx. Okay, and a square root in the parentheses, in the denominator, is not using the parentheses type. However, you can rewrite it, right? You can rewrite as x squared x to the power 3 minus 1 to the power negative 1/2 dx. Okay, so it becomes similar to the previous part. We have parentheses, we have power, so eventually your composite function is power type, right? And we have to choose, at least in this case, x to the power 3 minus 1 as the term we're going to substitute. Okay, so our t of x, u should equals to x to the power 3 minus by 1. Okay, and our du should equals to 3x squared dx. Okay, and we also observe, if we set x to the power 3 minus 1 as g of x, and our x squared dx only cover part of the du, and we have an extra 3. That means you are going to bring the 3 to the other side, become 1/3. Okay, so what do we have? We have now u to the power of negative 1/2 and 1/3 of the u. Okay, and this is the blue part. This is the yellow part. Okay, and again, two rules apply. 1/3, the constant multiplication, and u to the power of 1/2, that's negative 1/2 plus by 1. So you have 1/2 as the final power. And this power should be flipped upside down, become 2 to the front. That's a power rule, right? And plus by a constant c. So this is a power rule, and this is a constant multiplication rule. Okay, all right, finally we have to simplify and also bring the g of x back. So you have 2/3, and with x to the power 3 minus 1 with 1/2 plus a constant c. Okay, and it's an option. You might use square root. So you might want to say 2/3 square root of x3 minus by 1 plus a constant c. So it doesn't matter which one you use. With power 1/2 will be fine. Written in the square root type will be fine. Okay, but you got to have x in there, and you have to replace the u away. Okay, So that's question number 12. Okay. Now, number 14. Number 14. And here we have x squared divided by x to the power 3 minus by 3 dx. Okay. And in the denominator, we don't have any power, and that means power 1. Okay. All right. So you might want to check. In addition to this possible substitution g of x, the left part contains of g prime or not, and happen to be 3x squared, and we do not have a 3x squared, but we have x squared. It's proportion to the 3 times x to the power 2. So it's probably okay. That means we can use u as x to the power 3 minus 3. And our du becomes 3x squared dx. Therefore, our x squared dx is again part of the du. Part of the du. Okay. And that means we need to do the rewrite. And first bring the denominator replaced by u. And the numerator part become 1/3 of du. And since we do not have anything in the numerator of the original term, that means 1 is here. Okay, it's multiplication, so nothing there means 1. Okay, so this is a substitution of the x squared dx, become 1/3 of du. And the denominator rewrite as a function, as a variable u. Okay. All right. Now, the basic rules, including 1/3 constant multiplication, and also rule number 6, right? Logarithm. So we have ln of absolute value of u plus a constant c. So that's rule number 6. And constant multiplication, what's that rule? Rule number 3? I think that's rule number 3, right? I'm not really remember what's the order of this. Okay, anyway. So that's step number 4, right? And last step, we have to bring the u function. We have to bring the x variable back to the position of u. So our final result should be 1/3 of ln absolute value of x to the power 3 minus by 3 absolute value again plus a constant c. Okay. All right. Now, question number 22. e to the power of negative, not negative, positive 2t plus 3 dt. Okay, and it bothers us if we have an exponential with power more than variable. So we have 2t plus 3. So it suggests we might replace that to a single variable u. So you might say your u is equals to 2t plus 3, and that will give you your du will equals to 2 dt. Okay, and it happens that dt is here, but not the whole part of the du. Unfortunately, we only have 2 as the different coefficient, and that's easier to take care. All right, so we are going to have e to the u, and dt become 1/2 of du. So the power in the exponential function will be replaced by u, and the constant one-half to the front, dt replaced by du. Okay. Okay. Now the integration includes only the variable u and happen to be applicable by the basic rules, including constant coefficient to the front, that's 1/2, and e to the power u, that's the rule number, I believe this is rule number 3, and this is rule number 5, right? Exponential rule, right? Okay, now the last step. Bring back the variable t. So u is equals to 2t plus 3 with a constant c to the front. Okay. All right. Now, starting with integration of a variable t and end up with a result of a function in terms of a t. So that completes the whole process. Okay. And so far, we have been discussed by using substitution and bring the basic rule and come up with the final result. And well, I may ask, are we doing the right work? So you can check by take a derivative of this result to see if they are exactly the same as the integrals. Okay, so if you take a derivative of this part, you have a to the front and cross away with 1/8 and become power 7. So we have power 7 in here, and inside that's a composite part, so you need to have g prime, and g prime happen to be 4x, so we do have that one. Okay, so the first exercise, question number 2, is correct. And then you can check the second one. 5 to the front is 1, and power becomes 4. And inside the parentheses, after derivative, we have 3x squared plus by and minus by 2x plus by 1. Happen to be a terms in here. Okay, so you can do the double check to see if your integration substitution technique or the basic rules is correctly applied. Okay, you can double check for that. All right, and we do have some of them, so let me check one more time for the question number 10. our result is in here. So you multiply, you take derivative on this part, you bring down the 5 and multiply by 1 over 30 become 1 over 6, and you have power on the 2x to the power 3 plus 3 has power 4, and inside the parentheses you got to have a g prime, which is 6x squared, and cross away the 6 with the 1 over 6 become 1. Okay, so we do have the correct solution for number 10. Okay, and for the number 12, using this form might be easier. So we bring down 1 over 2, and power become negative 1/2. So we have 1/3 to the front. And inside the parentheses, we have x to the power 3 minus 1. The derivative becomes 3x squared. And cross away 3 with the 1/3 is coefficient 1. Okay, happen to be exactly the same thing as this. So we do have the correct solution for this particular question. Okay, now the result in here, and ln, the derivative for the composite function, ln the derivative become 1 over x to the power 3 minus 3, and then inside that part we have to do the derivative multiplied to the end, and happen to be 3x squared, and cross away 3 with 1/3 is coefficient 1. Okay, so it's correctly applied. And last question, number 22, the derivative of this particular one, e to the power of 2t plus 3, the derivative of 2t become 2. 2 multiplied by 1/2 become 1. Okay, so we have correct solution. All right, and in this stage, especially the beginning of the semester, all the practice must be double checked to make sure you are correctly applied. Okay, and don't let any error become your minus point in the exam. Okay, and let's take a break. We are going to do something else later. 10 minutes.